So throughout this section, I have dictated which method needs to be used in which example. Okay, so whether it be difference of two squares, factorising, completing the square or quadratic formula, I've said, right, this is the method that you're going to use that, no other. Okay, from now on, it's a free-for-all. So you can use whatever method you are comfortable with using and which is appropriate to the question that you're considering. So you're going to get a little bit of insight into how I kind of work through a quadratic equation and kind of my order of thinking. Usually, the first thing that I will look for is, can I factorise it? But generally, if it's not difference of two squares, or it's not got a coefficient of the x squared being 1, then I very quickly don't bother looking at factorising. So if it's got 2x squared equals 2x squared plus other stuff, I usually don't bother looking at factorising. The reason for that is, unless I've been told to factorise, there are easier ways than that, because I could go through the factorising process and then find out that it doesn't factorise. Okay, so that feels like a bit of a redundant step to me. So what would I do next? Well, if I can't factorise it, will I be able to complete the square fairly easily? And that's usually down to the coefficient of the x squared and the coefficient of x as to whether that's a way through. If I don't like the look of that, or I think it's going to be quite tough, I'll probably go into using the quadratic formula. But the quadratic formula is usually my last ditch attempt. So that's really kind of like my order of thinking. So these four examples have a quadratic equation on both sides of the equal sign. The first thing that we're going to need to do is to rearrange it so that everything is on one side of the equal sign and zeros on the other side. Okay, and then we'll get on to solving. So with the first one, what I'm going to do is I'm going to subtract everything from the left-hand side. Now, the reason why I'm doing that is so that I can end up with a positive value of x squared. That seems like a good plan. So I'm going to have 0 left on the left-hand side. So if I subtract x squared from both sides, I'm going to get x squared left on the right-hand side. I'm going to subtract 3x from both sides, so I'm going to get minus 5x on the right-hand side. And then I'm going to subtract 5 from both sides, and I'm going to get plus 4. Okay, now I've ended up with a quadratic where the coefficient of x squared is 1. So my first instinct is, can I factorise it? Okay. So two numbers that multiply together make 4, but add together make minus 5, would be minus 4 and minus 1. So this one factorises. Okay, so that means that either x is 4 or x is 1. Okay, so that one, factorising was good. I could spot that reasonably quickly. Okay, let's go to number 2. So number 2, we've got the largest power of x, largest number of x squareds on the left-hand side. So if I subtract everything from the right this time, I can subtract an x squared from both sides. So I'm going to get x squared on the left-hand side. Subtract the 7x from both sides, and we get minus 12x on the left-hand side. Subtract 10 from both sides, we get minus 13, and that's going to be equal to 0. Okay. So the coefficient of x squared here is 1. So can this factorise easily? Two numbers that multiply together make minus 13, but add together make minus 12, minus 13 and positive 1. So x take away 13, x plus 1 equals 0. So x equals 13 or x equals minus 1. Okay, so another one where it was easy to spot that factorising worked. Okay. Right. How about number 3? Now, number 3, I think we're going to subtract everything from the left-hand side this time, because then I'll get a positive number of x squareds. And that's easy to work with. So 5x squared take away 2x squared is 3x squared, minus 9x, take away minus 5x, or just add 5x to both sides, rather. Add 5x to both sides would be easy to visualise, wouldn't it? So you get minus 4x. And then subtract 3 from both sides, we're going to get minus 4. Okay, so this is a quadratic where the coefficient of x squared isn't 1. So I'm going to quickly abandon factorising. I don't know whether factorising, if it can be factorised or not. You know, you can't tell that immediately. Is this one where I would like to complete the square? Not really. I'm going to have to factor out 3. I'm going to get minus 4 thirds. I'm going to get thirds involved. I could do it by that. But I think I might as well just jump straight into the quadratic formula. So x is going to be minus b. So minus minus 4, so 4, plus or minus b squared, so 16, take away 4 times 3 times minus 4, all over 2a. So 4 times 3 times 4, so that's 12, times 4 is 48, plus the 16 is 64. So 4 plus or minus 8 over 6. So 4 plus 8 is 12, divided by 6 is 2. 4 take away 8 is minus 4, divided by 6 is minus 2 thirds. Okay, so it would have factorised. It would have factorised to 3x plus 2 times x take away 2. So if you spot the factorising, fantastic, well done. Complete the square would have worked. Well, works with all quadratic formula otherwise. Right. Let's take a look at number 4. So we've got the 3x squared over here. So let's subtract x squared from both sides. So 2x squared. Take 3x from both sides, so take away 4x. And then take 1 from both sides, so minus 7 equals 0. Now the coefficient of x squared here is 2. So I'm not liking factorising. So will I complete the square? Well, complete the square looks like it's probably going to be all right, actually. So I'm going to go with that method, I think. So factor out the 2 from the first 2 terms. Complete the square on what's inside. X take away 1 squared, take away 1. Multiply through. So minus 2, then take away 7. Okay, so if we add 9 to both sides, divided through by 2 in one step, 9 halves, square root both sides, we're going to get plus or minus 3 over root 2. So x is equal to 1 plus or minus 3 over root 2. The answers. I don't really like having root 2 in the denominator if I can help it, so let's rationalise the denominator. Multiply top and bottom by root 2, we're going to get 3 root 2 over 2. And so they're my answers. So no, it wouldn't have factorised. And so I could have spent some time trying to find a way of factorising it unnecessarily. Okay, so hopefully this has given a little bit of insight into what my kind of like thought process is on order of priority of like what I'm looking for. Can I factorise it from the off? If not, shall I complete the square or shall I use the quadratic formula?